Hello everyone! So here we are in the 5th unit that we're talking about in Algebra 2, talking about factoring now again with polynomials. That's right, factoring is back, and it's bigger than ever. So one thing that you might find or need to find in your notes as we kind of go through some examples today is this factoring reference foldable that we made back in the Unit 4 when we first started talking about factoring. So that's just actually last chapter ago, but it was months ago really. And what does it mean to factor and why we use it is to help us solve or to find those solutions. So these methods are going to come back for us. We're going to continue to use them, but the problems are going to be a little bit more complicated. So please remember that to factor means to break apart into little parts that were multiplied. So the strategies that we're going to use are the same, but the answers and the problems look a little different now. And now that we're dealing with those higher order polynomials or more pieces, more terms, higher exponents, we're going to be using the same strategies, but our answers are going to look a little different. So this is the first one I need you to get in your notes. We're going to take another look at greatest common factoring. And if you don't want to write all the words, that's fine because you have that in your foldable. But it's when we look for a common thing you can take out of all the terms. So the reason we do greatest common factor first is because you should always ask yourself if there are any factors in common before doing any other type of factoring. So this is your number one go-to. This is the thing you always check first. It makes the problem easier if you do this first. So as I look at these two terms, I notice there's a 50 and a 25. So I would ask myself, what's a common number that I can divide out of both 50 and 25? The greatest number that I can divide out. And the answer to that is 25 itself. I can divide 25 by 25 and 50 by 25. I also look at these little x deals, and I need to take some x's out as well. They have x to the fourth x squared. That means I can factor out an x squared from both of them. Once I decide what it is I'm taking out, this is the greatest common factor, then I actually do the factoring, and that is I divide it out of each piece. So 50 divided by 25 is 2, x to the fourth, but I'm taking two of those little x's out, so x squared, he now becomes x squared left on the inside left. Okay, 25 divided by 25 is a minus 1. And x squared, but I divided those x squareds out, so he has no x squareds left. So this is what it looks like when it's factored. So these are the factors that multiply to make that. That would be my final answer at this point. Later on, we will continue and solve them, but for right now, again, we're just taking a look at the factors. Another way we factored was using group factoring. What you're going to notice now is we still have 4 terms, right? But some of the numbers get a little bigger and the exponents get a little bigger. So remember with group factoring, we go ahead and place them into 4 boxes because there are 4 terms. And 15 here, and we once again divide out of every row and column the greatest number and variable that can be divided out. So 30 and 18 can both be divided by 6, and they can both have an x squared taken from them, so 6x squared. This row, negative 25 and 15, can both be divided by 5s, but I think I'm going to take a negative 5 out here because that row starts negative. And now I'm going to go up like this, 30x to the third and negative 25x. Well, I take a 5 and an x out. And up this last column here, negative 18x squared and a 15, I'm going to take a 3, but I'm going to make that be a negative 3 since that column starts negative. And again, you can check by multiplying like you would do in science, okay, with the whole genetics deal, and you can check your answer and make sure it makes sense. But our two factors would be 5x minus 3 and 6x squared minus 5. So before we were getting like 5x minus 3, 6x plus 5 or something like that. Now we're going to see some higher exponents in our final answers. So we also then, after group factoring, talked about what if you have 3 pieces. So these are trinomials in quadratic form, it's called. So 3 pieces, we want to take a look at trying to get them to turn into 4 pieces to fit in the 4 squares. So we used the AC method, ladies and gentlemen. So AC method, one more time, is us taking A times C, negative 24. Okay, negative 12 times 2 is negative 24. What multiplies to make negative 24 and adds to make negative 5? Negative 8 Positive 3 will do that. So once I decide those are the little guys I'm going to use, then I stick them in the 4 boxes. The A and the C remain constant in our problem here, but we replace the negative 5x with these two guys over here that we said are the same thing as negative 5. So negative 8x and positive 3x. And we do the same thing we would do for group factoring or greatest common factor. I'm going to divide a 2x out of those two, divide a 3 out of those two. Going up, I'm going to take just an x out of those, and here a negative 4. So my two factors are x minus 4 and 2x plus 3. So those are my factors, and that would be my final answer if it said to factor. What you're going to notice on some of our higher level ones now is some of those powers are going to be a little different. Another example of this AC method. Take a look at this guy. Okay? Remember, we have higher exponents here. So one of the things we always want to do and remember to check is that greatest common factor idea. So the first thing I'm going to do is take out a greatest common factor because there is one. 4, negative 20, 24, they can all be divided by the number 4. So the first thing I'm going to do is take out a 4 as well as some x's from each of those. I'm going to take out an x squared since they all have enough. They can give me that. And see what this problem looks like after I do that. So if I take it out of the first term, 4 divided by 4 is 1, x to the 6th, but I'm dividing out an x squared. That would leave me with x to the 4th left. 6 minus 2 is 4. Negative 20 divided by 4 is negative 5, and he'd have x squared left. And then 24 divided by 4 is 6. He had x squared, but I'm taking him out, so he doesn't have any x's left. So first thing I did is greatest common factor. Now, we're not done. Just because we do one thing doesn't mean it's completely factored. This guy still has 3 terms, and that's still a trinomial that could be factored. So we still need to take a look at how we just factor that piece. Now, because he's a trinomial and he has 3 pieces, we want to turn him into 4 pieces. We're going to do the AC method. Now, the A and the C, don't worry about this guy out here. He's the greatest common factor. The A and the C are 1 and 6. So what multiplies to make 6, if I multiply 1 times 6, and adds to make negative 5? Remember, it could be negative 6, negative 1, or positive 6, positive 1, or 2, 3, or negative 2 and negative 3, since 2 negatives multiply to make a positive. We're looking for the ones that add to make negative 5. Once I decide which partnership or which pair I'm going to use, then only this trinomial here, this little guy here, goes in the 4 squares. X to the 4th minus 2x minus 3x. I'm taking those from our list over there. And then the 6 was the C value. So now we're going to take out something greatest, or we're going to take out things rows and columns, but I'm noticing I'm not quite done here. Remember that this was negative 5x squared? These have to be x squareds then, not just x's. Sometimes we're used to having an x there. You saw me just do it right there, but I forgot that those have to be x squareds. So I'm going to place the x squareds there in those middle boxes since my original problem had an x squared in the middle. So now let's do rows and columns. I'm going to take out here, just an x squared can come out of those 2 terms. These guys can be divided by negative 3. Going up here, what can I divide out of those 2? X squared. What can I divide out of those 2? Negative 2. Okay, so now our factors are x squared minus 2, x squared minus 3, and then don't forget that we've kind of ignored to this point this 4x squared. He's a part of the problem's factors. He needs to be listed as well. These are all of the factors that I would need to distribute in order to get my original problem back the way he started. So this idea of using greatest common factor to get it started and then continuing until we have him completely factored is what we want to keep doing and keep practicing now as we go. Okay. Let's take a look at some perfect squares. We also talked about difference of perfect squares. This is another example of that. So when you use the difference of perfect squares pattern, you're looking for perfect squares. That's what these two numbers are. And then the fact that there has to be a subtract sign there in order to use that pattern. So because I have 16 and an 81, I know that I can jump right to the factors. What is it that multiplies to make 16? Well, that'd be 4 and 4, because the square root of 16 is 4. Now notice I needed an x to the 4th right here. So putting an x and putting an x is not going to make me have an x to the 4th. I need to do x squareds here. Okay, x squared times x squared would make an x to the 4th. Now let's look at that 81 in the back. 81 is 9 times 9, 1 positive, 1 negative. Okay, so far so good. Now if I look at what we have so far, this one looks pretty good, but I'm noticing this guy right here is still a difference of perfect squares. 4 and 9 are both perfect square numbers. That means I can split him apart one more time. To make 4x squared is 2x times 2x. To make 9 is 3 times 3, 1 positive, 1 negative. And that first one is not a difference of perfect squares, so we can leave him as is because he does not follow the difference of perfect squares pattern. So all of these are the factors that would need to be multiplied in order to create this original problem. Okay, so we're talking about factoring and factoring completely now